Today we're going to be talking about our new megacell, which has been in operation now just since March of 2013. The reason that we began to work on this megacell is because of our customers. In the history of mold manufacturing throughout the whole industry since the dawn of the Industrial Revolution, mold makers have been taught to do things many different ways so that the one thing can be done more than one way. In fact, you could have 10 mold makers teaching 10 different ways to do the same thing. That won't work very well within an automated system. So although it worked for years and years, when you had one mold maker and one mold, it doesn't work very well in mold manufacturing. And frankly, customers aren't that keen on having things that are inconsistently built that way anyway. And they require basically three things from a mold shop. They would like to have molds that are built faster. They want shorter deliveries. They want molds that are cheaper. And through that process, they want to make sure that we do not lose the tolerancing. We get very close accuracies in our manufacturing. And in fact, that we even improve that. So in years past, this has been something that has been talked about within the mold making industry, that it's pretty much impossible. So really the route to that is going to be automation and robotics, running 24/7 and having the majority of those times be without men at the operating level. So that's what we've created here in what we call cell 1 of the megacell, of which there will be 4 cells on the insert side of manufacturing to build the mold inserts themselves, and then a 5th cell on the other side of our shop will have another rail system, a rail system that will actually build the mold plates themselves. So on this side we have the mold inserts being built, on the opposite side we'll have the mold plates being built, all through robotic automation. So this is the beginnings of it, which is cell number 1. Cell number 1 will take care of the blood and guts, I would say, of a mold, which is the plastic part itself, the features that will make the plastic part within the mold insert. In other words, the EDMing of that insert is primarily the blood and guts, I would say, of the mold insert. So here we have in the megacell the electrodes being manufactured. Actually, they begin offline before they even come onto the rack by being scanned into our system using this chip that you see on these pallets. So a little black circle on each pallet, which is a radio frequency chip that we use to identify exactly what's on that pallet, whether that be an electrode or whether that be a mold component. And those are fed or tracked through our entire system, all the way from mold design of that electrode or that mold component to the programs that are used to manufacturing it, and then also into the CMM, the inspection that it's going to take to assure that that component is exactly like it's supposed to be. All these things are tracked in the system, kept track of, particularly for the medical industry, what we call critical to function dimensions. The critical to function dimensions are those that our customer will require that be certified within the plastic component. Those are tracked through that computer chip and stored within our system so that we can pull them out for our customer once the mold is complete. But also we use that in the process of manufacturing the component to make sure that all our dimensions are to print, both in the first article inspection, which is the very first component, all the way through the number of components that are manufactured along the way to finish that particular electrode or workpiece, whether we be making the electrode or burning the workpiece in the EDM that I'm standing right in front of now. This machine is the latest model. This is a Mitsubishi EA12V. This unit has only been running since March. This particular machine is EDMing right now. The robot will feed both the electrodes and the mold components into it. But these machines are also set up so that we can run them manual or automated, and all the machines are set that way. And that is because sometimes we have components that need work on them during the day, that is maybe one component, but it has to be very accurate. We need to be able to pull this machine offline and keep the rest of the operation running so we get as much automated unmanned time as we can. But at times we will have a man on each machine during the day where we have to do something custom, and it's designed to do that. So we have large magnets that can go in any one of the machines, so we can actually put a component in that's not mounted on a pallet, but that's mounted on a magnet, which is palletized. And that'll allow us to do custom work during the day, and then we'll always have enough components within the controller to run through the night or through the weekend to be able to utilize this machine to its maximum in all of the time that we run the machine through the course of the week. So in other words, during the course of the day, they may do custom work sometimes, and then towards the end of the day, all they have to do is switch it over to automated, and whatever's already set up in the machine is already proved out that the first articles are good and the subsequent components are also going to be good. Then the machine is kicked into production and off it goes. During the course of the night, it will pull whatever it's working on into the CMM, and each component as it comes off will be verified that it is good as it runs its operation. If something happens during the night where it doesn't meet within the parameters that have been preset, the machine will call the operator who's at home and let him know that something has gone on, or it can be cued in to say if anything goes wrong, then it goes outside the parameters, it's okay. Eliminate that one out of your controller, we'll work on it in the morning, and we'll move on to the next piece that's been proved out. So we maximize the amount of operation that this can run at all the way through the night or through a weekend. And now we'll move to station number 2, which is our Aji Sharmi Series 350 EDM machine. This also is the latest model. It has a FO 350 SP EDM machine. But while we're here, we'll talk a little bit about how we set up the machines and how we organize the construction and the building of the electrodes as well as the work pieces. And everything that we design and manufacture is engineered according to the center line of this pallet mounted gauge ball that I have here in my hand. So what you see here is a System 3R macro pallet. On it is mounted our gauge ball that we manufacture ourselves. So it has a computer chip on it, and it has the gauge ball, and there's obviously a certain height from the bottom of this to the center line of this ball. So anything that we manufacture works off that center line, and no matter how this is rotated, that center line never moves. So we can pull dimensions from our CMM, or actually even on a surface plate manually. We can set this up at any angle and pull dimensions from this ball to any surface that we need to manufacture, whether that be EDMing or machining, turning. It really doesn't make any difference. All facets of both the electrode and the mold component are made to the center line of this ball. That would mean the outside of the piece when we're grinding it, the milling of the component when we're working inside of it, any laser engraving, wire EDMing, jig grinding, all those operations will be done through this mega cell as we move it down the line. Right now, of course, only cell 1 is in place, but by the time we finish through cell 4, all the operations I just talked about and more will be done on the mold component and all manufactured to the center line of this particular gauge ball. So this is the second machine. We have 2 EDMs along this cell on this side, 2 machining centers on the other side. What I'm looking at right here is there's a draining station right outside of here. So the larger 12 by 12 System 3R Dynafix pallets will be actually put in here. They're tipped, they're drained, so that before they can go on into the rack or back into the machine, we actually pre-drain them off before that happens. So that's as far as the EDM side is concerned. And now we'll be moving on to some of the other stations, ancillary stations within the system. Here we have an open door where we can load and unload our Dynafix pallets. They're very heavy. And down at this level, we can load them in, and then the robot can put them in onto the bookshelf, which is off to my right here. Over on this side, we have where we can transfer into the macro pallets, the magnum pallets, the intermediary sizes that are much smaller than the Dynafix. So what we can do in here is components obviously they're as large as 12 by 12 or smaller than this pallet. So depending on the size of the component, we would mount it on one of 3 sizes of pallets. The robot can change its switch arms to be able to handle any of the three. Robot sitting right outside of me right now, it happens to be loaded with a switch arm for Dynafix pallets at this particular time, but it can change its arms out to where it will also handle the Magnum and the Macro pallet. This is where the larger pallets, the Dynafix pallets, are stored. And now we'll move on to the area where we actually do the programming. Along here we have our station, our loading station, where we have our gun, and this is where we actually assign the computer chip to what's on this pallet. Once we identify what's on this particular pallet, and then it's loaded on into the magazine, then the system will recognize what we've assigned to it, whether we're telling it that it's a gauge ball and that's what it will use to set its X, Y, and Z coordinates, or whether that be the workpiece that we put in there and it actually does machining to this pallet. It's all logged within this particular system. There are two rotary pallets back there holding right at 500 mold components. That's a combination of both electrodes and mold components. And right now, like, you can see that the robot is getting ready to change out its arm, and it will switch out another arm, and it's grabbing it right now. And what that will be is the switch arm. So you'll notice that that particular arm has two places to grab, and so it will go and retrieve a pallet from the carousel. It will take it to a machine, and the blank set of fingers will go into the machine first. It will remove the component from the machine, flip the switch arm, put the component in that it just removed from that carousel into the machine. Therefore, in one trip, it can both remove a piece and put another one in, so it saves a little time that way. Right now you can see that it has retrieved an electrode, and there is a reduction pallet from the 12 by 12 that's gone down to the macro, and is now going to put that mold insert in there so that the CMM can verify that it is correct. Obviously what's happened is the machining centers over to my right here have machined that component and put it onto the rack. The electrode has retrieved that component and brought it in here for inspection. The type of software that we use to operate this cell is a Workshop Manager of System 3R. And along with that, in the CMM, we of course have a Zeiss CMM, and the software that we use to run that, as we're converting to, is all based out of Solidworks. So our engineering begins with Solidworks mold design, and from the Solidworks mold design we use Delcam, which is a Solidworks partner, in order to associate our design to our programming for both the machines that are being operated as well as the CMM, so that we stay within the same software, which is Delcam, and then also Power Inspect, I believe, is the software that we use, is also a SolidWorks derivative. But we try and stay within SolidWorks partners, and whenever we're either inspecting or we're EDMing or we're machining, it's all within the same partner so that we can associate all of the designs, programming, and inspection all within itself. Any change that's being made then we can regenerate very easily without having to have manual data input in any of those softwares in order to make any kind of corrections or changes that may have to go on in order to actually build a mold insert. And now we can move on to around the corner. So here I'm in front of the Edm Programming Station, and you can see we have a card out here that has the programs that have been set up by our programming department, the inspection sheets, everything is laid out here to be able to go into the controls. On the pallet we have some ancillary components. So you'll notice that on the CMM machine you have the robot loading into the 12 by 12 Dynafix, but we also have an ancillary manually operated receiver over off to the right. The reason for that is the CMM is not used all the time within the cell, and a mold shop really can't afford to be buying a whole lot of CMMs, but you still need this to check other things that are outside the cell. So what we do is, whenever the robot is not being used and the CMM is not being used to check a component within the cell, what we'll do is manually load in the ancillary receiver, and be able to provide inspections for someone outside the cell that needs something checked and made sure that it's verified to be correct, because virtually everything within the shop has to be verified correct, whether it's inside the cell or outside the cell, before we can move on to the next stage. So the software that's inside of here obviously runs the Zeiss CMM. And now we move on to the Standards and Procedures Manual. So every area within our shop, whether it be EDM, whether it be grinding, IDOD grinding, surface grinding, our laser area, our mold makers, machining centers, every area will have one of these books. This particular one happens to be for the megacell. In here are all our standards and procedures that have been created. Now, this particular cell has only been up since about the end of March, but we've been working on these books for more than a year prior to that, making sure to build our standards and procedures to be able to operate not only the cell, but to operate better outside the cell. So we've engineered this system to be able to do each and every operation that we do, no matter how small and minute, only one way. And that's what these books are all about, is everyone in this plant, all 82 people, are in a continuous improvement team meeting once a week, where they sit down at a table and they grind out any irregularities in what they do. They work on a whiteboard in order to divide the board and put down all the different ways on one side, and on the other be able to agree as a team that step one will be only one way, step two, step three, step four. Once the teams create this one particular methodology, you have what we see in front of us here. This is a flow chart, and this flow chart shows that you will do step one before you can move to step two, three, and so on before you finish the end, and then this particular thing that's at the top of the page will be completed in the same fashion regardless of who does that particular operation. This is exactly how it's done. And this book is full of many different things like that. These are also ISO documents. What we've done is take the standard ISO document that you see written out like this, which is very hard to understand, and turn that into a flow chart that's much easier to understand, easier to teach, and make sure that everyone works in a consistent fashion. So whether it's inside the cell or whether it's outside the cell, the object is that everybody's doing things the same way. We build more of a manufacturing unit that way and less of a mold making custom environment. So now we move on to our machining centers. We have two Machinos, and one with the fifth axis and one standard. This one here, this is an E33 electrode machine. The other one is a V33 with the fifth axis. Both machines are loaded identically, and because we have this many machining centers and only two EDMs, you can see that these machining centers will make a lot more electrodes than can possibly be used in this cell at this particular time, until we add more EDMs as we increase the cell. So the additional electrodes that are made in this cell are used in a room outside of here where there's another 8 EDMs. So all electrodes that are EDM'd within Rexam Mold Manufacturing are all manufactured within the cell and certified within the cell, whether they be EDM'd within the cell in an automated fashion or whether they be EDM'd outside the cell in a semi-automated fashion in the room outside where we're looking at right now. And now we walk into the last section, which is our V33 graphite machine. But here you can kind of see that there's the two carousels on the opposite side. We were on the other side prior to that where the EDMs were, and now we're on the opposite side. We've just gone all the way around the cell. This is rail one that you've just finished looking at. You see the readers on the outside. There's reader arms on the outside of the carousel that line up with the black EDM chip on there. As this carousel makes one revolution, those readers will read every one of those chips. That assignment section where we were at on the opposite end, where I showed you the scanning, that's where it figures out, okay, we've scanned that piece. We now know there's a drawing model associated with it. We know there's a set of programs that are associated with it and some inspection that's associated with that particular chip, that particular component, and then every machine that it runs through, that's how it tracks it. So with all those readers, one on each row, one revolution, it knows exactly where everything is. So every time this door is disturbed, Those carousels will make a revolution to make sure that everything is either where it thought it was prior to that, or it will find out what you just disturbed within there, and it'll also track that. Have to do that to make sure that nothing is left per chance. So everything is automated in that fashion.